We get a bit more function notation in Chapter 4, and more or less, anytime you see a function symbol like the letter f of x or g of x or any function notation, you can replace this in your mind or physically if you need to with the letter y. These will work interchangeably with each other, and so any questions that's posed in this section, I think for the most part, if you just scratch out the function notation and put a y in, you can get all the answers that you need and not deal with the function notation. But you should get comfortable with function notation because it definitely comes up if you have to take more math classes after this class. So this section's titled Linear Functions. Linear means line and their properties. And the big thing about lines that we need to remember is the y equals mx plus b form, at least for now, where the m is the slope and the y-intercept is the point 0b. In this notation, in this section, instead of having equations in the form y equals mx plus b to represent lines, we're going to have equations in the form some function like f of x equals mx plus b to represent equations of lines. And that's exactly in problems 1 and 2. Problems 1 and 2 give me functions that will graph to be lines, and they're written in function notation as opposed to xy notation. If I go to answer each of the parts of number 2, 2a wants me to find the slope of the line f of x equals 2x minus 10. The f of x is working like the y. The m is the 2 in front of the x. For 2a, there's no algebra to do. The slope of this line is going to be 2. And when I go to sketch a graph, I can use that 2 if I think of it as 2 over 1 and go up 2 and right 1. Just in case you forgot that. Part B wants me to find the y-intercept. To find y-intercepts, we plug 0 in for x. So when I go to do part B, I'm just going to plug 0 in for x and go f of 0. Oh heck, it's in... I'll do this, but I could have got the y-intercept because it's going to be this negative 10. Because this is in slope-intercept form, the y-intercept is going to be the 0, negative 10. But I wasn't thinking that when I started this. In general, to find a y-intercept, I plug 0 in for x. The algebra for problem 2 is going to give me f of 0 equals negative 10. And when I go to write the answer to this as what the y-intercept is, it has to be a point. All intercepts have 0 for the other letter, so the y-intercept is going to have a 0 for the x, and the y part's going to be negative 10. The reason it has a 0 for an x is because I plugged in 0 for x to find that intercept. Part C wants me to find the x-intercept, and that's the trickier one with function notation. Usually, when we go to find an x-intercept, we plug 0 in for y. In this case, we don't have a y. I'm going to replace the function symbol with a 0 to find the x-intercept. So as I go to find the x-intercept in part C, I'm going to set 0 equal to 2x minus 10, and I'm going to do the algebra to solve for x. Specifically, I'm going to add 10 to both sides. That's going to give me 10 equals to 2x, and then I'm going to divide by 2. And that's going to give me 5 equal to x. When I go to write my answer for part C, I'm going to say the x-intercept is the point 5, 0. Always when you're finding an intercept, the opposite letter is 0. In this case, I'm finding the x-intercept, the opposite letter is y, and it is 0. So done with A, I found the slope, B, I found the y-intercept, C, I found the x-intercept. Now I'm going to sketch a graph. There's multiple ways to do the graph. One way to do the graph is just to plot a point and use the slope. So I could plot the y-intercept at 0, negative 10, and use the slope. Go up 2, right 1, up 2, right 1, up 2, right 1, up 2, right 1, up 2, right 1. Eventually, if I do that, I come across the x-intercept. The x-intercept, because it's a point on the line, if I'm moving in the direction of the slope, in this case up 2 and right 1, I'm going to come across the x-intercept at some point. now finish up my graph by just connecting these points with a line. On the next problem, when I go to sketch a graph, I'm going to be less, plot less points, I guess. And I won't use the slope. I could have, when I went to graph this, I could have just plotted the x-intercept and plotted the y-intercept and connected them. And all the other points that I marked here are going to be on that line. They're not going to be marked, but they're going to be there. So done with part D, sketch a graph. For part E, to determine the intervals where the graph is increasing, decreasing, or constant, we've done increasing and decreasing. I'm not sure that constant comes up in this section or not. It doesn't come up here. I'll mention constant when it actually is relevant. This graph doesn't have any maximum points or minimum points. It doesn't have any turning points in some sense. So as I move from left to right, this function never changes directions. So it's only going to be increasing. Technically, when I go to do increasing and decreasing, usually I put negative infinity on the far left edge of the right axis, positive infinity on the far right of the edge of the x-axis, and then any point between the infinities where there's a turning point, I put that x-coordinate on the x-axis. Because there's no turning point, there's no extra numbers to get on the x-axis, and this entire graph is only going to be increasing, and it's going to be increasing from negative to positive infinity. When I go to answer part E, so this D is the graph right here. When I go to answer part E, I'm going to say this graph is increasing in the interval from negative to positive infinity. And then if I want to, I can say for decreasing, it's never. But you don't have to say that. It's implied that it doesn't decrease when you say it increases from negative to positive infinity. And similarly, we haven't got to constant yet, but it's never constant either. All right, so that's everything for number 1. Hopefully you can go through and do number 2. I'll flash up 3 and 4, and maybe you can do these just fine without me. For problem 4a, wants me to find the slope, and the function that's given is g of x equals negative 4x minus 8. It's in function y equals mx plus b form, so the number in front of the x is the slope. The answer to 4a is the slope is going to be negative 4. A lot of times I'll say m for the slope just because I'm used to using that letter. But ultimately, the answer to this, the negative 4 is the important part. If you say m equal to negative 4, I'll understand that means slope. If you just say the slope equals negative 4, we'll be fine too. For part B, to find the y-intercept, I could do what I did for problem 2, plug in 0 for x to get that y-intercept. But because this is in y equals mx plus b form, or f of x, g of x equals mx plus b form, that number after the x, that negative 8, is the y-coordinate of the y-intercept. The y-intercept is going to be the point 0, negative 8. For part C, to find the x-intercept, I replace the function symbol with 0 and get 0 equals negative 4x minus 8. I'm going to add 4x to both sides and then divide by 4. I need to get the letters on one side, the numbers on the other. And in this case, if I do the, I don't know why I did this, but I want the number in front of the x to be positive. That's why I did this. I added 4x to both sides to get the letters on the left side, the numbers on the right side. And now I'm going to divide by 4. My algebra is going to give me x equal to negative 2. And when I go to write the answer, I need to write that as a point. As a point, the x part is negative 2, the opposite letter y is 0. Now if I went to graph this, I could just plot the intercepts of 0, negative 8, which is the y-intercept, negative 2, 0, which is the x-intercept, and I can be done with my graph. If I wanted to use the slope is negative 4 over 1. So to get from point to point, I would need to go down 4 and right 1. If I started at this point and went down 1, 2, 3, 4, and right 1, I'd go off my screen. Starting at this point, if I go down 1, 2, 3, 4, right 1, down 1, 2, 3, 4, right 1. Eventually I wind up at the x-intercept, or the y-intercept. So for graphing, you don't have to use the slope. If you have both an x and a y-intercept, if you simply plot the x and the y-intercept and connect them with a line, you'll get the same graph as if you use the slope to find points as well. This point came a little bit off the line because I kind of didn't have a grid down here to make it so accurate. So you should be able to do number 3. Oh, I haven't done part E yet. For part E, so this is 4D. For part E, this graph doesn't have any turning points, so as I go to answer the increasing, decreasing, and constant part, I'll put negative infinity on the far left edge of the x-axis, positive infinity on the far right edge of the x-axis. There's no more numbers to put on the x-axis because the graph doesn't change directions. And this graph, as I move from left to right, is moving down. So this graph is decreasing over that entire interval, negative to positive infinity. So when I go to answer part E, where the graph is increasing, decreasing, and constant, I'm going to say this graph is decreasing in the interval from negative to positive infinity. And if I want to, I can add that it's never increasing and it's never constant. But you don't have to include the never part, but you can. So that hopefully is enough for you to do question 3. Now we'll move on to 5 and 6. And 5 and 6 are tricky because when I look at problem 6, it gives me the equation f of x equals negative 2. When I go to work with number 6 to find my slopes and my intercepts, I might have to think of this of f of x as f of x equals 0x minus 2, because this simplifies to just f of x equal to minus 2, because the 0x is equal to 0, so this is equal to f of x. This is the same as f of x equals minus 2, but it will make it easier for me to answer the question. So when there isn't an x value in a function, you can definitely slip in a 0x, and that function will equal the original function. When I go to do part A, now it's going to be easy. The slope is the number in front of the x, which is a 0, because now it's in kind of y equals mx plus b form, the function notation of it. The y-intercept is going to be, there was 0 comma that number, so the y-intercept is going to be 0, negative 2. The x-intercept is sneaky. To find the x-intercept, I replace the function symbol equal to 0, so I'm going to go for x-intercept. I'm going to go 0 equals to 0x minus 2. And this 0x is really just 0, so I'm going to really go 0 equal to minus 2. This is a false statement. If there's no letters in an equation and the statement is false, there's no solution to that. So this is going to have no solution, which means there's no x-intercept. The answer for the x-intercept is that there is none. So now when I go to sketch a graph, I'm going to plot the y-intercept, which is the point 0, negative 2, and I'm going to use the slope. The slope is really 0 over 1, so I'm not going to go up or down, but I'm going to go right 1. So I'm going to stay flat. I'm not going to go up or down, but I'm going to go right 1. So the first point, I'm going to go right 1 and not up or down. The second point, right 1, right 1, right 1, right 1, right 1. So I can get as many points as I want by simply going from point to point, going right 1. So it's right 1. And the line is going to be a horizontal line that's parallel to the x-axis, because there isn't an x-intercept. When you don't have an x, you get a horizontal line that's parallel to the x-axis. So this is for part 6D. And when I go on to do part 6E, to find the intervals where a graph is increasing, decreasing, or constant, I put the infinities on the edges of my x-axis, and then any number between the infinities where the graph has a turning point or a maximum or minimum point, I would put those x-coordinates on the x-axis. I don't have any more numbers to put on the x-axis because there aren't any turning points. And this function, as I move from left to right, it doesn't get higher, nor does it get lower. It stays constant. It's constantly at the same level. It's not going up or going down. So for this function, to describe what it's doing, this is constant over the interval negative infinity to infinity, And for the increasing and decreasing, it's never increasing and it's never decreasing. And again, you don't have to include the never parts in your answer, but you can. So you should be able to do number 5. I generally don't ask questions like 5 and 6 on the test, so it's not probably the biggest deal, but it's good to know. All right, so I'll move on to question 8. 8a wants me to find the slope of this equation, this function. Because it's in y equals mx plus b form, the slope is the number in front of the x, which is 3/4. Could write m equal to 3/4 if I want. Because it's in the kind of function y equals mx plus b form, the y-intercept is the number after the x term, and it's always 0 comma something. This is the y part of the y-intercept. The opposite letter, in this case x, is going to be 0. And for part C, the x-intercept is a mess, and maybe I'll use my calculator. For the x-intercept, I set the function equal to 0, or I plug in 0 for the function notation. I get 0 equals to 3/4 x minus 6. Now I'm going to add 6 to both sides and get 6 equals to 3/4 x. And then if you want to be not clever, you could divide both sides by 3/4 to solve for x. On the right-hand side, if I divide by 3/4, the 3/4 cancel, I'm left with the x. On the left-hand side, to do 6 divided by 3/4, if I don't know how to do that, I could do it on my calculator. Go 6 divided by, I'll put 3/4 in a parentheses to be safe, and 6 divided by 3/4 is 8. If I didn't want to be clever, I could have done this. This right-hand side is really 6 divided by 3/4. I can write it as a divide sign as opposed to a fraction. And dividing by a fraction is the same as multiplying by the reciprocal. So that's really 6 times 4/3. And I can think of that as 6 over 1 times 4 over 3. Multiply the 6 times 4 and get 24. Multiply the 1 times 3 and get 3. And then 24 over 3 is going to be 8. So my x-intercept answer is going to be the 0.80. When I go to sketch a graph, I can plot the y-intercept, 0, -6. I can plot the x-intercept, 8, 0. And if I want to use the slope, I can go up 3 and right 4 to get more points. So maybe up 1, 2, 3, right 1, 2, 3, 4. Up 1, 2, 3, right 1, 2, 3, 4. Up 1, 2, 3, right 1, 2, 3, 4. So I don't have to use the slope to graph my line, because if I just plot the x and the y-intercept, my graph is going to be adequate, because it's going to be the same graph that I get even if I don't do the slope part of the line. For the increasing and decreasing, all lines are, so this is the answer to 8D, all lines are either increasing everywhere from negative to positive infinity, decreasing from negative to positive infinity, or constant from negative to positive infinity. When I'm asked to determine the intervals where a line is increasing, decreasing, and constant, there's only one interval. It's the interval from negative to positive infinity, because there aren't any turning points. This graph, because the slope is positive, as it goes from left to right, is going up. And so this graph is increasing everywhere in the interval from negative to positive infinity. It's never decreasing and it's never constant, and I'm not going to use the never in my answer. All right. For problem 9, I don't see the part E, but I'm going to add the part E, figure out where it's increasing, decreasing, and constant. Somehow that must have got cut off my screen. I'm not sure why. So when I go to do problem 10, I have to think of problem 10 as f of x equals -1 x over 3 plus 6. Because the number in front of the x is a negative, it's implied to be a -1. And better yet, I can sneak that x off to the right of that fraction and think of problem 10 as f of x equals -1/3 x plus 6. All of these, the original problem, the first rewrite, and the second rewrite of the problem, are all equal to each other. You can get any of the answers from any of the forms. This third form is probably easiest for me. So when I go to answer 10a, it's in function y equals mx plus b form. The slope is the number in front of the x. So the slope in this case is going to be negative 1/3. For part B, the y-intercept is that number in the y-coordinate of the y-intercept. Always when I'm finding an intercept, the opposite letter is 0. The opposite letter of y is x, so the x is 0. When I go to do the x-intercept in 10C, intercept, it's probably easiest for me to work with this version. So I'm going to set that version equal to 0. So negative 1/3 x plus 6 equal to 0. I'm going to add 1/3 x to both sides to get some positives as opposed to a bunch of negatives. If I would have minus 6 from both sides, I would have had negative on the left side and negative on the right side, which is not my favorite. Now I'm going to divide both sides by 1/3. On the right-hand side, the 1/3 are going to cancel. I'm going to get an x. On the left-hand side, I can pull out my calculator and do 6 divided by parentheses 1 divided by 3 and get 18. Or on the left-hand side, I could have thought of this as 6 divided by 1/3, and dividing by a fraction is the same as multiplying by the reciprocal, so this is really 6 times 3 over 1, and 3 over 1 is equal to 3, so this is really 6 times 3, and I could have gotten that 18, the x part of the x-intercept by hand. My answer to part 10C is the x-intercept is going to be the point 18, 0. All of a sudden that doesn't fit on my graph, so I'm going to bring another sheet of paper here just to do a graph of this, and then I'll worry about the increasing and decreasing part that I didn't have on here either. So when I go to sketch a graph for 10D, the y-intercept is the point 0, 6. So 1, 2, 3, 4, 5, 6. So the y-intercept 3, 4 is on the y-axis at the point 0, 6. And the x-intercept is at 18, 0. I don't feel like making 18 little marks to get to 18, so I'm going to mark by 2 on my x-axis. So my x-intercept is the point 18, 0. Now I'm just going to connect the points. I'm not going to use the slope to do the line. The reason I'm not going to use the slope of going down 1 and right 3 is because I didn't graph this on graph paper. If I start going down 1 and right 3, I may not wind up, if I start at this point, I may not wind up at that point because my intervals, my gaps between the numbers aren't accurate enough to use the slope to move around on my graph to get to another point that I have to get to. So if I went down 1, right 3, down 1, right 3, I might not actually stay on this lines because I didn't use graph paper. So there's my graph. Now for this one, it's decreasing everywhere. Lines are always decreasing, always increasing, or always constant. This graph is decreasing for the entire graph from negative to positive infinity. It doesn't have any turning points. Lines for the increasing, decreasing, and constant part, it's always going to be only doing one of the three things. And in this case, because the slope is negative, it's always decreasing. Alright, so I'll flash 9 back up there just in case you need to... Whoa! 9's the same problem as 10, so I just did your problem 9. Funny. Wow, that's brilliant. Alright, next group of problems, getting ready for a break in my video, give us functions for f of x and g of x, and they ask us to find some, solve some equations and inequalities. And these are supposed to be easy. When I go to do problem 12, which is kind of my version of your number 11, each time I'm asked to solve a part, I'm just going to take the function symbol and replace it with what it's equal to and do the algebra to solve for x, or isolate the x. So for f of x equal to 0, I'm going to replace the f of x with negative 3x minus 2. Had a hiccup there. So for 12a, I'm going to replace the f of x with minus 3x minus 2 and solve for x. To solve for x, I'm going to add 3x to both sides. I don't like all these negatives. I don't like a negative being in front of my x. And when I do that, on the left side, the 3x's cancel. I'm left with a negative 2. And on the right side, I have 3x. And now I'm going to divide both sides by 3. When the number in front of the x is positive, it just makes my math easier. And I'm going to get, for an answer to 12a, negative 2/3 equal to x. For part B, I'm going to do essentially the same thing. I'm going to replace the f of x with negative 3x minus 2, and I'm going to solve for x. I'll do this in a different color just to separate the problems. So I'm going to solve minus 3x minus 2 is greater than 0. When you're dealing with less than or greater than signs, there could be a need to switch the direction of the inequality. So I'm going to switch a greater than to a less than, or a greater than or equal to a less than or equal to, or a less than to a greater than, or a less than or equal to a greater than or equal to, if I divide by a negative number to solve for x. If I don't divide by a negative number to solve for x, then I'm not going to switch the direction of the inequality. Let me do part B to show you when you'd switch the inequality. So I'm going to solve for x by this time adding 2 to both sides, which is probably instinctively what you might do. When I get this to this point, this gives me minus 3x is greater than 2, and I'm going to divide both sides by a negative 3. The only time I switch a greater than to a less than is exactly what I just did. If you divide by a negative to solve for x, then you flip the sign. So this is going to give me, on the left side, x. I divide it by a negative, so I flip the inequality. And on the right side, 2 over negative 3, it looks funny to me to have a negative in the denominator of that fraction, so I'm going to move it up to the numerator. For my answer to part B, I'm going to say x is less than negative 2/3. I could have solved that similarly to how I solved part A. And if I would have solved this like this, if I would have said minus 3x minus 2 is greater than 0, if I would have added 3x to both sides, that would give me minus 2 is greater than 3x. And then I would divide both sides by 3. Now the number in front of the x that I'm dividing by is positive, so I don't flip the sign. I only flip the sign if the number I divide by in front of the x is negative. This as an answer would give me negative 2/3 is greater than x, because the left side would be negative 2/3, the right side would be x. These answers look different, but they're equal to each other. So the x is written on the left side in the original answer that I came up with. The x is written on the right side in the second answer I came up with. I can tell these answers are equal to each other because in both versions, the pointy part of the inequality is pointing towards the x, and the open side is pointing towards the 2/3. So the answer that I got for part B of number 12 is the same as negative 2/3 is greater than x. There's actually 2 correct answers to problem B of number 12, depending on which side you have the x on. As long as the opened end of the sign is pointing towards the negative 2/3, it doesn't matter which side the x is on. To do part C, I'm going to change the f of x to minus 3x minus 2. And I'm going to change the g of x to minus 2x plus 8, and I have the equal sign between them. So for each of these problems, we're just changing the function notation to the what it's equal to, and then I'm solving for x. The nicest way to solve for x in this problem is to add 3x to both sides to get the x on the right side, which will make a positive number in front of the x, and to minus 8 from both sides to get the number on the left side. When I do that combination, on the left side, the 3x's cancel. The numbers in front of the signs in front of the numbers are both negative, so I'm going to add them and keep them negative. That's going to make a negative 10 on the left side. On the right side, negative 2x plus 3x, 3 minus 2 is 1, so I'll get a positive 1x, and the 8's cancel. Solving the problem this way, I get directly to my answer. And of course, you can rewrite that answer with the x on the left side if it bugs you to see the x on the right side in the answer. For part D, I'm going to change this f of x to negative 3x minus 2. And I'm going to leave the less than sign, and I'm going to change the g of x to the minus 2x plus 8. If I solved it like I did the problem above it, I'll get to an answer a lot better. So I'm going to plus 3x to both sides and minus 8 from both sides. When you're adding or subtracting, that less than sign can't switch. The only time you switch a sign is if you divide by a negative number to solve for x. Adding and subtracting is not dividing by a negative number to solve for x, so I don't flip the sign here. Algebraically, on the left side, the 3x's cancel. On the right side, minus 2 minus 8 is minus 10. Here I get negative 2x plus 3x is 1x, which is just x. And that's going to be a good answer for part D. So one answer I could write for part D is negative 10 is less than x. The other way that I could write this with the x on the right side, left side, and the negative 10 on the right side is to keep the open end of the inequality pointing towards the x. So that would be the best way to solve this problem. If you solve this problem getting the x on the left side, so if you would have done this, if you'd have said negative 3x minus 2 is less than minus 2x plus 8, you'd go, if you did this, if you did plus 2x to get the x's on the left side, plus 2 to get the numbers on the right side. On the left side, negative 3x plus 2x is negative 1x. Negative 2 plus 2 is 0. When you're adding or subtracting, the less than sign stays a less than sign. The negative 2x plus 2x is 0. The 8 plus 2 is 10. And now I'm going to divide by a negative 1 to solve for the x. This is when I have to flip the sign. Anytime I'm dividing by a negative number to solve for the x, I have to flip the sign. This would give me x is greater than negative 10. On the left side, the two negative ones cancel, leave me with an x. Divide it by a negative, so I flip the sign, and then 10 divided by negative 1 is negative 10. You get that version of the answer as opposed to this version of the answer. But with inequalities, it doesn't matter which side the x is on, just as long as the opened end of the inequality is pointing towards the same feature. In this answer, the open end of the inequality in the blue version and the red version is pointing towards the negative 2/3. In this version, the open end of the inequality is pointing towards the x, and they're both correct answers. I usually like to avoid flipping signs if I can. So here's your problem 11, so give it a go the best you can. And here's your problem 13. Maybe give that a go as well. I'll do 14, but with the idea that you've probably already could do 11 and 13 without me doing 14. So if you can do 11 and 13, fast forward through the part of the video where I do 14. So 14a, set f of x equal to 0. F of x is 3x minus 6. To solve 14a, I'm going to go 3x minus 6 equal to 0. To solve this, I'll add 6 to both sides and get 3x equal to 6. And then I'll divide both sides by 3. And I get for my answer to part A, x is equal to 2. When I go to do part B, I'm going to set f of x greater than 0. F of x is 3x minus 6. So I'm going to set 3x minus 6 is greater than 0. The algebra is going to be the same. I'm going to add 6 to both sides and get 3x is greater than 6. And then I'm going to divide by 3. The only time I flip a sign is if I divide by a negative. That 3 is a positive that I'm dividing by, so I don't flip the sign. My answer to part B is going to be x is greater than 2. For part C, setting f of x equal to g of x, I replace for the f of x 3x minus 6. I leave the equal sign, and in place of the g of x, I put 4x plus 4. It's easiest for me to minus 3x and minus 4 from both sides to get my x solved for. If I minus 3x from the left side, the 3x's cancel. If I minus 4 from the left side, the numbers are both negative. I add them and keep them negative. Bring down my equal sign on the right side. 4x minus 3x is 1x. 4 minus 4 is 0. My answer, I can write negative 10 equal to x, or I can write x equal to negative 10. It's up to you. If it bugs you having the x on the right-hand side, you can just flip that, and it means the same thing. For part D, I'll do it two ways. One way where I have to flip the sign, the other way where I don't have to flip the sign. So I'm going to put 3x minus 6 in for the f of x. I'm going to leave the less than sign, and for g of x, I'm going to plug 4x plus 4. I'll solve it for flipping the sign first, so I'm going to minus 4x and plus 6 from both sides. This is one way to solve this. This is the way I wouldn't generally solve this. Solving it this way, on the left side, 3x minus 4x is negative 1x. The 6's cancel. I bring down the less than sign. On the right-hand side, the 4x's cancel. 4 plus 6 is 10. Now I'm going to divide both sides by negative 1. When you divide by a negative, you have to flip the inequality. So this is going to give me x on the left-hand side. Flip the less than to a greater than. On the right-hand side, 10 divided by negative 1 is negative 10. This is a correct answer. Or you could write the negative 10 on the left side, the x on the right side. The open end of the inequality needs to stay pointing towards the x. Those are both correct answers. The other way to solve this would be to avoid having to flip the inequality. If I did 3x minus 6 is less than 4x plus 4, I could have minus 3x and minus 4 from both sides. And if I solved it that way, I'm going to wind up getting this version of the solution, but I won't have to flip the inequality, because the only time you flip an inequality is if you're dividing by a negative to solve for the x. Solving it this way, on the left-hand side, I made the 3x's cancel. The minus 4 and minus 6 give me a minus 10. I bring down the less than sign. I don't flip it when I'm adding or subtracting. On the right-hand side, 4x minus 3x is 1x, and the 4's cancel. That answer is that version of the answer, which is the same as x is greater than negative 10. As long as the open end of the inequality is pointing towards the x and the pointy end is pointing towards the negative 10, these mean the same. So I'll flash 13 back up there just in case you didn't get a chance to do it. And then we have some word problems to do. And I'm going to try to sneak this all in one video. I'm debating how many word problems. Oh, there's not that many. There's like 4 word problems, I think. 3 word problems. I think I can get the 3 word problems done and keep the video under an hour. So your problem 15, I'll flash back in a little bit because you probably can't do it now. My problem 16 is supposed to motivate you to be able to do 15. And it says OSU. I probably intended that to be Ohio State because I was born in Cleveland. Ohio State University had 28,000 students in 2014 and 29,500 students in 2016. Assume that the growth is linear. Create points in the form enrollment and use 14 for the year 2014, 16 for the year 2016. Well, I didn't even read that right. Create points in the form year, comma, enrollment, and use 14 for 2014, 16 for 2016. Part A, create a linear function to model the data. So in this problem, in the first sentence, we're given information, and the information comes in pairs. The first pair is that in 2014, there were 28,000 students at Ohio State. And the second information is there were 29,500 students in 2016. The first sentence gives me information to generate points, and I'm told create points in the form year, comma, enrollment. So the 2 points that are going to be implied, the enrollment's going to be the y, because I'm told to make the year, comma, enrollment. So the enrollment of 28,000 is going to be the y of my first point, and the 29,500 is going to be the y of my second point. So I'm creating points of the form year first, enrollment second. So the year is the x, the enrollment's the y. The enrollment of 28,000 and 29,500 are the enrollment. The X's are 2014 and 2016. That's the years. But instead of using 2014, I'm just going to type in 14 because it says use 14 for 2014 and use 16 for the year 2016. So I've created points that model the information that's given, and snuck in the problem it says assume that growth is linear. That means if I find an equation of a line that fits that data, I can use that equation to make predictions about the enrollment in future years. Part A asks me to create a linear function to model the data, and to create a function that has an equation of a line, I need to find the slope and then use the y minus y1 equals m times x minus x1 formula. So I'm going to do part A down here. So for part A, to create a function, I have to first find the slope of that line, and the slope I'm going to get by doing y2 minus y1 over x2 minus x1. The y2 is 29,500. The y1 is 28,000. The x2 is 16. The x1 is 14. And I'm going to do this on my calculator. I don't care to do this by hand. So for my slope, I'm going to go parentheses 29,500 minus 28,000, close out my parentheses, type a divide sign, and then the denominator 16 minus 14 needs to go in a parentheses. So when I entered this on my calculator, I put the entire numerator and the entire denominator in a parentheses. And when I hit equals, I'm going to get my slope. Well, if I did it right, this is supposed to be a parentheses and not a divide sign. When I hit equals, I'll get my slope, and my m is 750. And now I'm going to use the y minus y1 equals m times x minus x1 formula. In for the m, I have to plug 750. And in for the x1 and the y1, I can pick either of the points. I'm going to pick my first point just because the numbers are smaller. So I'm going to go y minus y1. I'm going to put 28,000 in for the y1 equals 750 times x minus x1. I'm going to plug 14 in for the x. I'm going to clear the parentheses and get y minus 28,000 equals 750 times x, which is 750x, minus 750 times 14. And that's going to be minus 10,500. I almost have an equation of a line. I just need to, I added a 0 there. I just need to add 28,000 to both sides. On the left side, when I do that, I get the y. On the right side, when I do that, nothing happens to the 750x, but this negative 10,500 plus 28,000, again with the extra 0, I get 17,500, and it's plus 17,500. So I'm wearing out, so I'm pulling out my calculator maybe more than I should, but I would expect you to do the same. So my answer to part A, it wouldn't be wrong to say the equation of the line is y equals 750x plus 17,500. When I read the myself problem 16a, it says create a linear function to model the data. Linear means I needed to find an equation of a line. Function, it probably means it wants a function notation instead of the y notation. So if I wanted to be just literal, I can say for a better answer to problem A, I can say f of x equals 750x plus 17,500. That's a completely fine answer. Best would be to change the letters to have a little more meaning. So for best, maybe I'll say the enrollment based on the time is 750t plus 17,500, and this is almost getting silly. Using the letter E to stand for enrollment. I was going to do Y to stand for year, but that almost was going to be too confusing because you have that Y that wouldn't line up. Usually for years we use the letter T. Regardless of what answer you give me, even if you don't give me an answer in function notation, as long as you have the 750x plus 17,500, I'm completely fine. Part B wants me to use the function to estimate the enrollment in 2021. So I need to put something that represents the year 2021 in for the letter that represents the time. The letter that represents the time is the X. So I'm going to plug a number that represents the year 2021 in for the X into my equation. And for 2021, I'm going to use the number 21 because for 2014, I used 14. For 2016, I'd use 16. I'm going to use this version because that's probably the easiest for you. To answer this question, to find the enrollment in 2021, I'm going to plug in 21 for the year, and the Y that I get is going to be the enrollment, because what I'm doing by plugging a number in for X is I'm plugging a number in for X, I'm getting a Y. The X stands for the year, the Y stands for the enrollment during that year. Now I'm going to do this on my calculator. So I'm going to go 750 times 21 plus 17,500, and that's going to give me the enrollment in the year 2021. Will be 33,250 students. Okay, so that's everything for problem 16. Your problem 15 is essentially identical, so I'll let you do it. Pause the video, and I think I'm going to do your number 17 and not do number 18, so I won't even show you number 18. I'll do number 17 just to give you one of your homework problems done for a change. Number 17 talks about a sub shop producing a used oven for $1,000. After 5 years, the ovens will need to be replaced, and it has a value of $200. Assume that the value goes down by the same amount each year. That's a sneaky way of saying that we can model the value of the function with a line, because a line, the slope is constant. It goes up or down by the same amount for every increment. In this case, the increments are years. So parenthetically, it says create 2 points. Let the X coordinate represent the age and the Y coordinate represent the value. I don't know what the age is because it's a used oven, but I'm going to say it's new to me. So my 2 points are going to have the Y coordinates are the value and the X coordinate is the age. The values are easy for me. The initial value of this oven is $1,000. And after 5 years, it has a value of $200. So I'm told to make points. The X coordinates are the age, the Y coordinates are the values. So I took the two values and wrote them in my Y coordinates. When the value is 200, the age is 5 years. At least it's 5 years old to me. It might be older than that because it was a used oven. And then the age to me, that when I bought it, I'm going to say it's new to me. It's 0 years old to me. It's new to me. So I'm going to put 0 for its age. For part A, I'm going to find a linear function to find the value of the equipment for the 5 years it's going to be in use. So what do I need to do for part A? I need to find a slope. To do the slope, I'm going to do y2 minus y1, which is 200 minus 1,000, over x2 minus x1, which is 5 minus 0. Do this on my calculator again. So parentheses 200 minus 1,000 divided by parentheses 5 minus 0 gives me the C. Just had a hiccup, so I did on my calculator 200 minus 1,000 in a parentheses divided by 5 minus 0. And that gives me negative 160 for the slope. And now I'm going to use the y minus y1 equals m times x minus x1 formula to get the equation of a line, linear functions in a line. In for the m, I'm going to plug negative 160. And in for the y1 and the x1, I can pick either point. I like this point better. And for the x1, I'm going to write the x coordinate of that point, which is 0. And for the y1, I'm going to write the y coordinate of the first point, which is 1,000. So this is going to give me y minus 1,000. And this side just simplifies to be negative 160x, because x minus 0 is just x. So this is really negative 160 times x, because x minus 0 is x, which I can write without a parentheses. Now I'm going to add 10,000 to both sides. I'm going to add 1,000 to both sides. Getting too many zeros here. Obviously, I'm getting tired, and that's never a good thing. So this gives me y equals negative 160x plus 1,000. So this was a 1,000. When I wrote from this line to that line, I added a 0. It should have stayed at 1,000. So an answer to part A, the equation that will help me figure out the value of this oven is y equals negative 160x plus 1,000. I'm asked to use function notation because it says find a linear function. So a better answer might be f of x equals negative 160x plus 1,000. And if you want to get really fancy, you can do v for value, t for the time in years. You could write v of t equals negative 160t plus 1,000. Each one of these three are okay answers for part A. This is probably the worst answer because it's not function notation and it wants me to find a linear function, which implies it wants function notation. These two are both fine, just as long as we know that x, the x coordinate stands for the age, and what I get out is the value of the oven. For part B, use the function to find the value of the equipment after 3 years. The 3 is going to stand for the x, so I'm going to plug 3 in for the x, or here 3 for the t. I'll use this version because that's what most of you probably will use. I'll go f of 3. The value after 3 years is negative 160 times 3 plus 1,000. So putting a number in for x, the x stands for the year, is going to generate a y, and the y stands for the value of the machine. Now it's just a calculator problem. So negative 160 times 3 plus 1,000. I get $520. So for my answer to part B, I'll say the value after 3 years. If you just wrote $520, that would be fine. So that's your 17. We have 19 and 20 left, and 19 and 20 are kind of brothered problems, or sister problems for what it's worth. If I lay 19 and 20 on top of each other, they're exactly the same problem with just different numbers. And this is the word problem that I usually ask from this section on the test. So this is the one to really focus on. So let me read through it. A real estate office manages an apartment complex with 1,000 units. When the rent is $600, all 1,000 units will be occupied. Hello. However, when the rent is $700, only 800 units will be occupied. Assume the relationship between the monthly rent and the number of units is linear, which means we can come up with an equation of a line to model this number of units rented. That says create 2 points. Let x coordinates represent the price, y coordinates represent the number of units rented. So the first thing I'm going to see, the price of $600, we have 1,000 units rented. So I'm going to create 2 points. My first point, the x coordinate's going to be the price, which is $600. The y coordinate's the number of units rented, which is 1,000. I'm trying to create 2 points. The second point is when the rent is $700, the x coordinates represent the price. So when the rent is $700, only 800 units will be rented. So those are my 2 points. Now I'm supposed to write an equation for the number of units rented in terms of the price P. So I'm going to I'm going to change these x's to p's for price. And I'm going to leave this as y's. So I'm going to have, eventually, I'm going to put a p in for the x. And I'm going to leave the number of units y. This says write an equation. It doesn't say write a function, so I don't need to write a function. I'm just going to leave the xy notation. And it says assume the relationship is linear. So I'm going to find an equation of a line that fits those two data points to get my answer to part A. So for part A, I need to find the slope. And to do the slope, I'm going to do y2 minus y1, which is 800 minus 1,000 over x2 minus x1, which is 700 minus 600. I think that comes out to -2, but I'm going to do it on my calculator to be safe. So I'm going to go parentheses 800 minus 1,000 parentheses divided by parentheses 700 minus 600. And I'm going to get negative 2 for the slope. And now I'm going to do y minus y1 equals m times x minus x1. In for the m, I'm going to plug negative 2. And in for the x1 and y1, I'm going to pick the first point. In for the y1, I'm going to plug 1,000. In for the x1, I'm going to plug 600. And now I'm going to clear the parentheses and solve for y. So I'm going to go negative 2 times x is negative 2x. Negative 2 times negative 600 is plus 1,200. And then I'm going to add 1,000 to both sides. And I'm going to get an answer for part A of y equals to negative 2x plus 2,200. I'm going to put that into my answer for part A. So I can, and a correct answer for part A is y equal to negative 2x plus 2,200. And the x represents the price. It's going to help me a lot if I change that x to a p. So I'm going to say a better answer for part A is y, the number of units rented, equals negative 2 times p plus 2,200, changing the x to the p, which is a price of what they're renting for. Having this version is going to make it easier to answer part B and part C. I didn't use function notation because I didn't say write a function. I just left my y there. So for part B, use the equation to predict the number of units rented when the price is $675. So I'm going to, into this equation, plug 675 in for the price because the P stands for the price. I'm going to get y equals to negative 2 times 675 plus 2,200. And calculator it. Gives me y equals negative 2 times 675 plus 2,200. And I'm going to get 850 units. And I could do a sentence and say 850 units will be rented at a price of $675. But when I go to write my answer, I'm just going to write 850 units will be rented. Done with part B. Part C wants me to find the price that will cause 950 units to be rented. Because the number of units rented represents the y, when I go to do part C, I'm going to use the equation that I came up with in part A, but in this case I'm going to plug the 950 in for the y, which is the number of units rented. The algebra that I'm going to do here is 950 equals minus 2p plus 2,200. And I'm going to solve it for p. I'm going to minus 2,200 from both sides. And on the left side, 950 minus 2,200 is minus 1,250. So this gives me minus 1,250 equals minus 2p. And then I divide both sides by minus 2. On the left side, I'm going to get the p. Or the right side, I'm going to get the p. And then 1,250 divided by 2 is, let me do it. Minus 1,250 divided by minus 2, I get 625. So a price of $625 will cause 950 units rented. And when I go to write my answer for this, I could just write 625 with a dollar sign, and that would be fine. If you want to write a sentence and say a price of $625 will cause 950 units to be rented, that's completely fine too. So I'm going to flash up 19, which is the last problem in this section that we need to do, and let you finish that up, and then I'll pause the video and do another one.